Rewrite the equation of the line square root of 3x plus y plus 2 equals to 0 into the following forms and find the specified parameters. Let's begin with the first one. So here in the first part of the problem, we need to convert the given equation into the slope-intercept form and determine the slope as well as the y-intercept. Okay, now we know that the slope-intercept form of a line is simply given by y equals to m times x plus c. So here m represents the slope of the line and c gives us the y-intercept of the line, and this particular format gives us the slope-intercept form of a line. So that means our task will be to convert, or you can say to transform the equation square root of 3x plus y plus 2 equals to 0 into the slope-intercept form. Okay, let us begin. So here we start with the given equation. So we have square root of 3 times x added to y plus 2 equals to 0. So we're going to only keep y on the left hand side, and then we're going to transpose the term containing x and the constant term to the right hand side such that we get negative square root of 3 times x minus 2. And if we compare it with y equals to mx plus c, then we're going to get m value equals to negative square root of 3, which is going to be the slope of the line, and the y-intercept value, the y-intercept, which we denoted by the letter c in lowercase, so that comes out to be equals to negative 2. So the first part of the problem is done. Now let's move on to the second part. We need to convert the given equation into the intercept form, and then we need to determine the intercepts on the coordinate axis as well. So let's quickly walk through the intercept form of a line. The intercept form of a line is given by x over a added to y over b equals to 1. So here x, that is going to the a, which is the denominator of the first term, that is going to be the x-intercept of the line, and then b, which is the denominator of the second term, that is going to give us the y-intercept of the line. So our task will be to first transform the given equation into the intercept form, and then we will figure out what is this x and the y-intercept. Okay, let us begin. So for this, what we'll do, we're going to keep the first term square root of 3x and the second term, that is y, as it is, but we'll transpose the third term to the right hand side to get negative 2. Now we're going to divide throughout with negative 2 such that we get square root of 3 times x divided by negative 2 added to y divided by negative 2, that is going to be equals to 1. Okay, now take the first term for instance. So here what we'll do, we're going to divide each of the numerator and the denominator with square root of 3 such that we get negative 2 over square root of 3 in the denominator. This is going to get added to y divided by negative 2. That's the denominator. This is going to be equals to 1. Now when we compare it with the intercept form of the line, so what do we get here? We get here that the x-intercept, the x-intercept, which we are going to denote by the letter a, that comes out to be negative 2 over square root of 3, and the y-intercept value, the y-intercept, which we denoted by the letter b, that comes out to be equals to negative 2. Okay, so let's move on to the third part of the problem. So our next task will be to convert the equation into the normal form. So here we have the equation of the line square root of 3 times x plus y added to 2 equals to 0. Fine. So let's do one thing. So here, and when we compare it with the general form of the line, so comparing with the general form of the line ax plus by plus c equals to 0. So here we get, so here we have the a corresponding to square root of 3, then b corresponds to 1, and the c value corresponds to positive 2. The reason why we wanted to figure out the value of a, b and c, because the general form of a line can be transformed into the normal form by taking help of this equation. We have negative a divided by the square root of a squared plus b squared times x. Then b times y is going to get transformed to b over square root of a squared plus b squared times y, and then c is going to be negative c divided by the square root of a squared plus b squared, that's going to be equals to 0. So this is referred to as the normal form of the line. So what we'll do, we're going to transform our given equation, which is in the general form, into the normal form. So for this, what we need here is the square root of a squared plus b squared. Now since a valued at square root of 3 and b is 1, so square root of a squared plus b squared simply gives us 2. Now we have the transform equation is going to be negative of a. Now we have negative square root of 3 divided by square root of a squared plus b squared, that becomes 2. This is going to get multiplied to x. Then we have negative b. So b is 1 divided by square root of a squared plus b squared, that's 2, multiplied to y. And then we have the c value, so that becomes negative 2 divided by 2, and that's going to be equals to 0. Okay. Furthermore, what we have here is square root of 3 over 2 times x. Then we have positive y, or half times y, and negative 1, positive 1 equals to 0. Okay, so we have square root of 3 over 2 times x plus half times y. This is going to be equals to negative 1. Now we know that cosine of 30 degree, that corresponds to square root of 3 over 2. So we're cosine of 30 degree replacing square root of 3 over 2 added to half. So half will get replaced with sine of 30 degree multiplied to y, that's equals to negative 1. Though what we're trying to do here is we're going to rewrite the equation in the form x cosine of alpha plus y sine of alpha equals to the perpendicular distance between the line and the origin. So this is what we need here. And as we can see here, the p is coming out to be negative 1. But we know that the distance must be positive. So let's do one thing. Let's rewrite the equation as negative cosine of 30 degree times x minus sine 30 degrees multiplied to y, that is going to be equals to positive 1. Now what is negative cosine of 30 degree? Now we know that cosine of, if we take 180 added to 30 degree, so that is also the same as negative cosine 30 degree, right? So let's keep it as multiplied to x. Then we have positive sine of 180 degree added to 30 degree, that is also negative sine 30 degree. So this is going to get multiplied with 1 equals to 1. And finally we get x times cosine of 210 degrees plus y times sine of 210 degrees, and this is going to be equals to 1. Now when we compare it with this form, so this is going to be the normal form of the line. This is the normal form of the line, normal form of the original line, normal form of the original line. So let's write down square root of 3x plus y plus 2 equals to 0. This we have expressed in the normal form, where we have obtained that alpha corresponds to 210 degrees and the perpendicular distance, that's equals to 1 unit. So hence we have successfully transformed each of the transform the given equation of the line into each of the three forms. One is the slope intercept form, the other is the intercept form, and the third one is the normal form.